So our scope today, we will cover what is MES, what is Styles Machinery and HOMAG's version of MES solution, and it's called ControllerMES, which we will go over those features and the benefits. So starting out today, I want to talk what is MES? Well, MES stands for a manufacturing execution system, MES. And basically this establishes a link between industry software or ERP, enterprise resource planning systems, to your production. It's basically the glue between the office and your production. So this is one of the main topics of today, of course, and this is what we look forward to educating and discussing with everyone today. Is an MES system right for you? So some of the questions you might want to ask is, do you wish to enhance your current production data? What does that mean? Is the information that you have available to your shop floor inclusive of everything everybody needs to know when they need to know it? Do you wish to improve your production output through intelligent batching, being able to batch jobs together to enhance the production throughput for your factory? Does continuous improvement require data collection or feedback from your production floor? Or do you require flexible production control and real-time monitoring of your production? And would you benefit from a more automated system or automated production processes? Is your annual sales expanding beyond your current manufacturing systems or your software or your production machinery? People ask many times is, at what volume level does an MES system really need to be required? And that's a good question. I try to put a dollar value on annual sales, and that's difficult because different companies work in different ways, but we'll try to discuss some of those topics also. Are you looking to get full use of your automated equipment that you may have already purchased from Styles Machinery? Are you hoping to reallocate some of the resources that were replaced by these machines on your floor? And are you hoping to eliminate production errors due to operator errors? Go paperless. Have operator guidance via digital screens or dashboards, and to automate your processes. So what is our MES solution? As I kind of stated a moment ago, it's ControllerMES. And ControllerMES is a manufacturing execution system. Our software and our system is a modular system. It's also very flexible and totally customizable. And understand that this is not a system that's just out of the box that I can sell you and you plug it in and it works. This is a project-oriented solution. What does that mean? That means that we build the solution for your manufacturing process. We sit down, we design the scope that you require for your manufacturing, for your software needs, and we deliver a solution for your requirements. And where does basic MES fit within the guidelines of your manufacturing? We look at this in two ways. You have the vertical method and then the horizontal method. The vertical networking, as you can see here, starts off with your current sales system, your order entry, how your data or your bill of materials are created, how you plan your ordering of materials, and you plan based on the schedule and your workload. And once it hits this particular line of your production control system, in this horizontal area, this is where ControllerMES lies. Basically, ControllerMES manages your storage system of your materials, whether it's an automated StoreTech IntelliStore system, whether it's a cutting on a panel saw, separating on a nested-based router, edge banding, whether it's a batch size 1 totally automated edge banding line, or we can also give previews on standard edging systems, aiding in sorting throughout each process from one machine to the next, managing getting the drilling programs to the right machine at the right time, all the way down to your assembly and your packaging. So this horizontal networking line is where MES sits inside of your production. It starts at the materials before you machine, and it ends at your truck when it loads the truck. So our MES system, as soon as it's loaded on the truck, is when we pass that data off to the next system. I like to show this screen quite a bit. This shows a lot. And using my pointer here, a typical manufacturing methodology today is you normally have some type of point of sale system. You're normally running some type of a CAD/CAM or bill of material generating system, whether it's a spreadsheet or a more complex order entry system or a design system, but you need to get a bill of material. So running this normal top line here, you come in from a sales into CAD/CAM. If you're running an ERP system already, then this line shows up to here. It goes from your CAD/CAM system directly to optimizing and nesting, and then goes straight to your production. And at that point, you kind of lose visibility of where everything is that you worked on up front. So one of the key features that MES brings in is we remove the step here. And now, based on this graphic, all of your data from the CAD/CAM system, the bill of materials for your one-offs, or if you're running an ERP and you have standard product lines, your bill of materials will come from here all together and then enter ControllerMES through our data configurator. And one of the features that we'll go over later on is what that data configurator does and enriches the data into production orders. And this is where we can then help you to generate production orders and create the production orders in a manner that maximizes the efficiency on the shop floor. And you'll notice here that these production orders will run the optimization or the nesting behind the scenes. And then once organized and ready to release, so then we aid in the planning, the organization of your production, taking that data, and then MES delivers to the production floor in the most efficient manner. And then once it hits the floor, we're also able to monitor your production, bringing back live data and live dashboards that we can see of telling you where your products, where your jobs, and how your machines are operating. Then once we collect all that information can also be passed back into an ERP system. So then you know with your current systems where your jobs and you're helping your costing information. So in this blue block is a critical component showing where ControllerMES fits in the environment or the data flow. Some, what I call ControllerMES at a glance, as an overview, some of the key features of MES, as we talked about briefly, is being able to create the production batches, being able to either automatically generate batches based on criteria or rules, or using dynamic filters within inside of ControllerMES to filter the jobs based on production date, also capacity planning to build those batches so that you know that when you release them to the floor that it's flowing your parts and your products at the most efficient method, because we have a visibility to every aspect of your production so we can see bottlenecks and predict bottlenecks before you release them onto the floor. Second big feature is the rework management. So that's another option we'll go over about the features later. We're also within MES able to generate data for batch size 1 edge banders. So if you have an automated edge banding system that requires programs or macros to run, ControllerMES will be able to generate that for you and pass it to the machine. Also allowing what we call an edge preview, which then gives you the ability for the operator to know what edging is required to bring up to the coils and magazines so he can change out ahead of time, so he can pre-plan for the day's production. Again, as we mentioned about monitoring and data collection off the machines, which is a very important part of knowing where things are and how things are running. So we collect all this information, we can monitor it live, so you can see at any given time if a machine goes down, you can see and know how that's going to affect your jobs coming up if you have parts that are still required for that machine. Again, ControllerMES does not generate CNC drilling, but we manage that. And I'll go over some of that a little bit later. We also deal a lot in sorting. And sorting can be done throughout your production environment. So after cutting, where the parts need to be sorted. After machining, where they need to be sorted. We can deal with sorting in carts. We can do sorting in pallets. And then we can sort and kit at the assembly area. So then you know that all of the parts are necessary for your assembly. We can also program packaging machines, also for what we call accessory picking for hardware, for other types of items that aren't being produced physically on the machine, but items that are required for the product in the end. We can allow for shipping control commissioning, meaning that we have all of the parts ready. When they need to be ready, we can produce RFID labels, we can do product labels, pallet information based on what you're shipping if you're doing RTA or finished good assemblies. And also we manage the stock control depending if you have like an IntelliStore system. We want to make sure that you have the right materials and also available before we release it to production. So in a general overview and a flow, as we mentioned a moment ago, we import data, your bill of materials, first into MES. It organizes all of this data and it validates that we have everything we need to run the machines. Because you may be designing a new product or a one-off custom and some parts that may need to be designed from one engineer who may be missing one part. So when your cut list or your bill of material gets imported into MES, we validate that and we import it, and then if it's not available, we stop, we give an error message before it hits the floor, and then the machining program isn't on the machine. Again, creating the dynamic optimization batches. We then allow you to identify the parts via barcode labels. Again, allowing and transferring the programs to the machines only when they're required. So we don't need to download weeks of production or store them on the machine for weeks at a time and accidentally deleted. So we're always making sure that the right programs are on the right machine at the right time. Again, we talked about generation of edge banding data. That would be also in there. We supply the CNC machines. Now the completion control is making sure that we have all part components required for that particular area. So as they go through the bander or as you're monitoring a job, we want to make sure that they're complete before maybe it goes to the next station or into assembly. We also can allow manual feedback from other operations or manual operations. So if you have our automated machinery, we're automatically getting feedback as the parts go through the machine. So we're reading data directly from the machine itself. If it's an area like an assembly or a hardware area or a sanding or something that there may not be automated feedback, we can set up a station on the floor so you can get feedback and monitor those particular areas of the shop also. And another thing is important we talked about is rework or defective parts. What happens when a part gets damaged? So we manage that. We can scan the part. We give screens on that, and I'll go over some of those in the features later on. And then we get into sorting and kitting. So this is a good overview of the process that MES would manage. Now we get into more of the features. To start, this is what we call a cockpit or your production cockpit. Again, because ControllerMES is completely customizable, your screen it's kind of like a dashboard, will be different in the office than you will have on the shop floor. So this screen would be more conducive of someone in the office that has control of everything. Then each one of these processes are each different area, whether it's reading feedback from a machine or whether it's seeing rework information. So this is our main cockpit. The screens on the shop floor, if necessary, will only show what needs to be seen on that particular screen. So being completely flexible and customizable, we can design the screens to meet your operator's requirements. So the operator gets what he needs to see when he needs to see it for what he's working on at that point in time. We talked about data validation and data enrichment. So when you have a bill of material and it's coming into MES, first thing we do is we then double check and make sure that the data is accurate and as accurate as we possibly can be based on rules. So if data is coming in and we have a lot of zero part quantities or zero sizes, or it's calling for certain machining programs that are missing, MES then throws up a flag and stops it before you even get it into a production order. So the data configurator can be set up so that it can enrich the data that comes in, which means that we can add part routing information. So if your ERP system has already a production routes, it's telling it that it's going to start off at a saw, then go to an edge bander, then to a CNC machine, then to assembly, we can then set up alternate routes. So if a machine is down for any reason or over capacity, that you can have alternate routes for those programs. So that is all handled in our data configurator. And then that gets passed over into our production order screen. This is where we began to build those dynamic batches that I was talking about. The first thing you want to see is, well, what happens if I batch these particular jobs together, and how does that hit the capacities of my bottleneck machines? So in this little example up here in the top left, I have a saw, an edge bander, and maybe my packaging area. So as I'm building these batches together, it then can show in different colors where I'm at on a given date for a capacity. So it helps you to balance the workload of your jobs, and you can see them in different colors. With this, we automatically run the optimization or the nesting behind the scenes. So once these batches are created, we just click a button and you go through these steps here. It will generate the optimization, and you'll see this behind this. This will be all done behind the scene, and then you can monitor what has been released to the floor, what's in production, what is planned for production, again with different colors and different machines, so you can see how it affects your given production date. We can also see the cutting patterns back into MES, just like you would view inside of the optimizer itself. But the difference here is we can also set up rules that if a particular optimization doesn't meet, for example, a minimum yield threshold. So let's say I set up a 70%. If it doesn't hit 70% yield on a given job, then it can throw a flag up for me. Otherwise, it may be automated. So it would then throw up a flag and say, hey, the batch that you just selected is below that. What do you want me to do? So then you could have a choice of accepting that and sending it on down, or you can go back to your open orders by dynamic filters that we have within MES, pick a job maybe from the next day, bring it in, and then see the results and see how that affects my capacities, and then it may increase that yield without affecting your overall bottlenecks in different areas. But one of the things that we are beginning to see quite frequently in our industry is called batch size 1. So the days of producing 50 or 100 of a given item at any given time are becoming less and less common. So today, in much of our manufacturing in North America, we're seeing the requirements that I need to produce 1. or 2 of a given product. So batch size 1 requires different methods of optimization, different methods of monitoring. So a lot of the systems that exist today, for example, you would have, if I needed to build 10 of them in one case and then 1 in another, I may have a quantity of 10 of a part, for example. Well, in a batch size 1 operation, we create a unique serial number for every part. So everything becomes a quantity of 1. So your existing systems, your existing ERP systems, your data systems may show I need 10 of a given item. MES automatically breaks that down into a quantity of 1. And then we generate the necessary data all behind the scenes. So you don't have to do this up front. So then we can track and we can monitor part by part, product by product, and job by job through the factory floor, no matter if it's a quantity of 1 or a quantity of 100. We still manage it the same way. And some of the advantages of this is that allowing with the dynamic optimization, we can increase the material yield, because as soon as you go to batch size 1 operation, what's the first thing that gets affected? It's your yield. Your yield goes down. Everybody thinks yield is very important, which it is, because that's a cost that you can look at, you can monitor, but how does that really affect the overall effectiveness of my production, and is it really that critical? But by allowing this intelligent batching, we can help you to increase that yield even in a batch size 1. We can reduce the setup times of your machines. We optimize the throughput. We also minimize the time between machine operations by maximizing the part types in between, so that helps your production flow better. And again, overall reduction in material cost by use of offcuts and reusing and storing those. We can do capacity checks, as I showed you, throughout the dynamic batch sizing, so we can see if I'm hitting, like this example, hits my top line up here, I'm at capacity for that day. So can I do something to reduce that? So we do check the capacities, and that's a decision that can be automated for you or manually controlled. Now we get into the data analysis and evaluation. As you can see, your production, as we talked about. So as the orders are being produced on the shop floor, you can see the progress of those products, and you can see the completion of those by product type, by order number. And then we collect all this information, and you can see what the capacities are on the machine, what the material consumption is at that given time, and we track this information long term. What does that do for me? That allows me to make smarter decisions in the future as I'm manufacturing similar type products or continuing to be dynamic in the type of products that I manufacture, because we can have all of this information stored about what stations and what machines, how many defective parts were produced over a period of time and why they were defective. We have the chronological progress feedback from different areas. Again, all the machines will have automatic feedback, but we can also set up stations so you can begin getting feedback from the manual stations that you may have never had information before, and where it's kind of like a black hole in your factory where parts may get lost. So this allows you to have a dynamic and a total overall view of your entire production and help you to identify bottlenecks before they occur. Again, by part tracking. So now, again, as I've already kind of talked about, we will be collecting this information through each area, tracking where all the parts are at any given time. And then here's the flash, here's the glimmer. This is the dashboard. So as you walk through some manufacturing facilities, or you walk into some even styles offices, we see dashboards of what our key performance indicators are. This is something that we can create within ControllerMES to view at different work centers. So as people see where they are in their production processes, or they can see maybe the stations or the workstations ahead of them are ahead of them, that can then mentally prepare these guys to work a little bit faster, work a little bit better and more efficient, so then they can be on time. Or your customers. These dashboards are very critical for you as owners or managers of your shops, but these views can also be shareable to your customers to see where their orders are. Another example of a dashboard, and this dashboard is something that we actually have set up in our High Point, North Carolina showroom as we run a work cell called our production cell. We have a B320 robotic panel saw. We have a KAL edge bander. We have a horizontal, or excuse me, a BHX style feed through CNC machine. We have a down inserter, horizontal drilling machine, and then we have a different area for sorting and kitting of doors, fronts, and our carcasses. So this is a snapshot of actually something we ran real, so we can tell the part quantities that we go through each machine, what has been released, how many more that I have to go. So again, this is just a dashboard that we put up so customers can see there, but this is totally 100% configurable. And as another example of our High Point jobs, we wanted to see by job or by customer where their production is in my shop floor. So this top one here is a particular, we called it Colorado Children's Hospital. So based on the saw, the edge bander, so we're complete all the way through, and we're 80% complete in assembly. And then these other jobs, as you go down through, you'll be able to see where they are at any given time, where they're at on the factory floor, either at a job level, or we can break it down further onto a machine, down to the part level. So we can see which parts have been produced already and which ones are still to produce. And we get into this batch size one. We call this the intelligent workpiece. I know many of you already have our CNC machines or our panel saws, so we're producing labels. So this is a typical label, which you have order information on, you have customer data, you have shipping information. So labels are common in the industry. Not everybody uses them, but when you do not have a completely automated factory, you want to have information that's legible and that's usable by the operators. Again, this helps to reduce paperwork. So the more information, whether it's visual or legible, on the label you have, the better. So in general, this information is standard. We can get this and pass it today. What we can do with ControllerMES is enrich that information. So for example, the first thing we talked about is generating a unique part ID. So if I come with my end panel or left side panel in this case, and I needed 10 of them, I then create a unique part ID specifically for that. Now I've got two barcodes here, same barcode, just in two different orientations. So as I scan into an edge bander, as I rotate the part around, then the scanner will automatically be in the orientation that I'm scanning. So that's one thing that we would do automatically in MES. The second thing is we can produce the processing routes. Some ERP systems, some systems already have a process route. That's great if you do. If you do not have that, ControllerMES can do it for you. We would then basically, based on a set of rules for a given part type, we can create, like this is going to my saw, then the next station is my edge bander, then to my CNC machine, and then it goes directly to the assembly. Whether it's in legible text or letters or numbers or colors, doesn't matter. We can produce these routes by whatever is required by that part, as well as alternative routes. So if I have multiple banders or multiple CNC machines that can process that, then we can also list those below or dynamically change that on screens on the shop floor. Another thing is this edge bander in feed direction. So what is important is, again, minimizing errors on the shop floor. It's one of the things we wanted to do. So we can, through MES, add this arrow, which means this is my first feed through direction of my edge bander. So when the operator picks up the part, He doesn't necessarily even have to look at this diagram of the label. He just looks at this. And the first pass goes in this orientation. So again, this is just enriched data. We also can show the zero line of the CNC point. So this right here is a dark line as an example again of if I manually put this part into a machining center, this is my leading edge that I go into first. We also have grain indicators that we can add so you can see the grain of the part. And of course, as you'll notice here, we even have this particular part had 5 edge processes. So we do a sizing on one, and then we go edge 2, edge 3, edge 4, and then we can show the picture of the edging diagram. Just more information we can see about the data enrichment that we can do for the operators on the floor. One of the other things we talked about a little bit earlier is how do you handle reworks or damaged parts? And I think this is one of the key features that in my discussions with companies is how do you handle reworks? Some companies have an entire separate area set up to handle reworks. Some people, they have to take a part back through the original machines that they begin and processed on originally. And depending on what phase they're in, you know, if this is in assembly and this job is getting ready to be loaded onto a truck and a part gets damaged, that truck is waiting on me. So I have to have that part now. You know, so now they have to go interrupt other production on all these other machines. And, you know, what effect does that have? And do you know that at later on, and how much money did that cost you? So the rework management is very important. With this system, we can set up terminals or any of our MES terminals, we can have a dashboard that you can simply open up and scan a part. It can be used simply as a quality control check that every 100 parts run through my bander, I want to check it. Or it is strictly for rework. When a rework is scanned, I basically have a reason, you know, what happened to it. I second have what needs to occur to reproduce this? Do I need to cut it from, you know, start from the beginning and cut it either on a router or a saw? Or do I just simply need to run it back on my CNC machine again because maybe a bit was completely broken on the CNC machine, just missing a hole? So these reason codes and actions are set up in here, which are customizable. And the operator selects that as they scan a part, they choose that information, and then that information is stored historically. And then we can trigger an action. So if a part needs to be reproduced, if I have a whole separate rework area, this could automatically be sent to the rework area. It could be run through the optimizer automatically and already on the machine ready to start cutting. Or if it has to be introduced back into my original machines, then we can set up times throughout the day that it introduces those parts back into your normal production. So that cockpit I showed you, as the person is batching, they would see all of the reworks that came in throughout the previous shift or even that shift. So there's many different rules you can set up with how to manage a rework, what occurs when a rework is necessary, and what steps needs to go through. And then again, we can look at this historically, and when you start seeing a trend that a given parts are needed to be produced on a fairly frequent basis in this area, then you can address it, whatever the problem may be, whether it's operator error, whether it's a machine problem, or whether it's data driven. So if it's something that your engineers need to go back and change the design of a product or whatever. We also get into what we call the production logistics or worker information. So we want to basically take digitization of production. That's hard to say. I won't try that again. So given the information available at a glance, this is where, again, we reduce paperwork. We want to give the operator what he needs when he needs it. So if he is at a station for assembly, for example, He scans a part. He sees that product that I need to assemble. He sees that hardware that I need to put together, and it tells you on the screen what's missing or what I need to get, what's already been produced. If something is missing, it's in rework. So then he can set that aside and go next. So again, worker information is very critical and is a big part of our MES system. Now we get into more fully automated lines. Anybody that may have had the opportunity to go to the previous Ligna show, we had a fully autonomous cell set up at the show, which is similar to what we have here as an example. And this was driven completely by MES. So when the jobs were released to the saw, we had whether it's a CNC nesting machine or a saw, robotically handled and then destacked. The AGVs are able to come over, and once a stack is complete, ControllerMES would then send a signal to say, okay, go pick up this stack of parts and take it over to this particular area and drop it off for the next operation. So it controlled the AGV information of when to go get it and where to go take it to. So that's what we call the transport orders. And then it manages the parts that are in there, so it can then set up the next machines in the line to know exactly what was produced and what was just delivered. And again, based on the capacity-based planning, then this all works together and is driven by our ControllerMES system. Now, another one, as we talked about, is the flexible sorting or shipping organization or kitting. This is something, again, one of the projects we recently worked on. They don't have automated guided vehicles, or they basically have panel saws sitting next to an edge bander, then multiple CNC machines, and then they have a second area for their assembly area. And what we do is, as the parts come off the saw, we indicate which cart or which pallet to set the parts on, so that they know they're organized by the next work process. So then if they need to go to the certain edge bander A or edge bander B, they're divided at that point in time by color code information on the label. Then that cart or pallet is taken to the next station. Once they run through the edge bander, then they're resorted again by the screen, saying, now I need to take these two. These go to my horizontal dialing machine. These parts go to my vertical machine. This one goes to a different machine because it can do both. Then as they continue to go through and cycle the sort throughout the factory, then we combine them all back together again as they go through and go into the assembly area. So that's one area of sorting. When, like in our showroom in High Point, we have kitting racks similar to what you see here on the screen, is there's slots. And in those slots, we define the size of the slot, how many parts can be in there. And we're sorting by, for example, the carcasses. And we got one rack as the parts are coming off of all the machines, the bander, the CNC machines. As they come in, the operator scans a part and it tells him which slot to go put it into. And you'll notice that it highlights, tells the operator we can also use an LED light to display where to go put that part. And these are the carcass parts. And then once a box is complete, then it can turn a different color. Then we also have a front rack that is dealing with our doors and drawer fronts, which may be coming from a different area of the plant. And we need to make sure those are all ready before we then assemble that unit. So if I'm missing something, it won't tell the operator to pull this kit of these products out until everything is available. So then that turns over on the opposite side of the screen. Then it shows which ones are complete. Then it begins assembling the carcass, grabs the doors and drawers, puts it on as it goes after the case clamp, and then on to production. What are some of the benefits of having an MES system? Well, we talked about this a lot, and I'll recap this. And this is data. Everybody has data. You need information to go to the shop floor. Well, as I've talked about, we need the right information. We need the right information at the right place at the right time. And we need to make sure that data is valid. And if anything that MES can do rule-wise to assist and to enrich or enhance information, because some systems that you have can only generate certain types of information. That's what the software does. That's all it can do. It may not have the information for the edge bander that you need. So we can enrich that data. We can also manage that fact that we can get the programs to the floor when they need it. So if an operator, it really eliminates the operator from deleting or manually editing or monitoring the programs on the machine. So as soon as that job is being produced, we have all of this information on a SQL database on a server ready to hit the floor. And also we talked about the planning and how we can flexibly and dynamically and intelligently create the most optimal batches to go through your production, which I think is a very important part of MES system. We can check the capacities of your different machines based on rules. And then monitoring the progress and the control of your production. Being able to store this information historically, giving you a flexible solution for different sorting availabilities and buffering. So controlling and monitoring and seeing the progress as it goes through is important. Now you'll know where the parts are, where they've been, and where they're at in the production if you're behind schedule or ahead of schedule on given jobs. Again, organizing your data, making it paperless, automating as much information as you can, eliminating errors, reduction of non-value added activities on the shop floor, managing your reworks, handling the data as it's getting ready to be packaged up, making sure you have everything available. Again, data quality, critical component. As we all know, we're getting into the batch size 1 production. Through MES, we can help aid in that. If your current systems are not capable of doing that, we can break down, we can produce a quantity of 1 as easily as we can a quantity of 500. Saving time on the shop floor, allowing this flexible batching and direct integration into the optimization or nesting system. We can improve those optimization results by allowing you and giving you foresight ahead of time by batching different orders together and seeing how it affects your production before you release it to the floor. Quick identification and processing of rework parts that are components that are very critical. Tracking of production and ultimately increase productivity. Now, with that being said, any questions as you go through, but I do want to leave you with a quick video. And this next video shows kind of the start to finish and what MES can do for you.
Wonderful. Thank you, Alan.